Hello everyone, it's MFK. In this video we are going to talk about what is ksqlDB tables. In the last video we have talked about streams, so I definitely recommend to watch that video first, which is in here or here in a card, and come here again please, so we will talk about tables. So what are tables? Tables are actually a mutable partition collection that models change over time. Unlike a stream, which is unbounded stream of events, a table represents now. What do I mean by now? Let's find out with an example. So in our example, we are a seller in the DC world. We have two warehouses in Gotham and in Metropolis. And in this world we are using Kafka, and we have a topic called fulfillment orders. And in this order topic we have ID code, a product count, how many items does order have, which warehouse, is it Gotham or Metropolis, and which city will this order go. And what do we want? We want to get the order count, get order count by warehouse. We want to get average product count and city of last order. I want to get this data just to show you a function, and we are going to get this stateful aggregated data with our ksqlDB tables. Before we start, I want to show you my Docker Compose YAML again. It's the same YAML as the last video, and in this video as well I will share with you our Docker Compose YAML and all the command in this video in the GitHub description. So we have again Zookeeper, Kafka itself, ksqlDB server and client, and we have our AKHQ Kafka UI, so we will produce messages with this UI project. So I will show my terminal. Okay, we have two steps. In the first step we have our Docker Compose YAML, and in this step we are going to have our ksqlDB server. Okay, let's create our server. Okay, and let's create our stream for this topic. We will create the topic as well. We have talked about streams in the last video, so I will just copy paste our stream and talk to you about this. So we have fulfillment order stream. As you can remember from the JSON body, we have ID code, product count, warehouse code and city right in our message. With our fulfillment orders topic we are going to have one partition. Okay, let's create our stream. Says created. I believe in Kafka, but just want to verify that, so I will say show streams. Okay, we have fulfillment orders. Kafka says true. Okay, clear. Okay, we want to get the product count, average product count, total order, and get the city of the last order, right, as continuously. So we are going to get our select statement and later turn that statement into a table. So we want to have select warehouse code as warehouse, maybe, yes, warehouse. We want to get count of orders, so it will be count of as order, total order count, total order count. We want to get the average of product count, right, product count, and last but not least we want to get the city of the last order. So how we can get that? There is a function called latest by offset, which gives us the last message by giving us actually last offset. So we want to get city in here as last city of order, yes, just last city, or from what is our stream name? It is fulfillment orders, right? And we want to get it grouped by warehouse. So we want to get this data by Gotham and Metropolis warehouses, right? So I will just say emit chains, and it says warehouse cannot be resolved because it's not warehouse, it's warehouse code. Okay, run again. Okay, right now our query listens and says, okay, we have warehouse total order count, we have our average product count. Let's give it a name that as well, as average product count maybe, and select that again. Okay, and we have our last city. Okay, now let's produce some data to our Gotham and Metropolis warehouses and see our results. Okay, this is our AKHQ UI, and this is our topic fulfillment orders we have just created with our stream, right? So right now it's empty, and let's produce some topic order here, get some money. Okay, our first order comes from Gotham and goes to Themyscira, which is the island of Wonder Woman, Princess Diana. Okay, now we have 5 items, right? To Gotham. Okay, let's produce it. And let's produce a message from Gotham to Coast City. It is the city of Green Lantern Hal Jordan. And we can get 15 item. So right now our average is 10, right? For the Gotham warehouse. And let's get some order for our metropolis as well. Okay, this is our order 3. We can have 15 for our metropolis, which can goes to Bloodhaven, which is the city of Nightwing. Let's produce that again and get to our terminal. Okay, as you can see, right now we are still listening from our query, and for the Gotham we have total order of 2. Our average count is 10, and our last city is Coast City, right? For the metropolis we have 1 total count. Our average count is 15, and we have Bloodhaven for our last city. So think like we can get this data within a table and we can always export that data to anywhere or reach this data via the REST endpoint. So how we can turn this query into a table? I will just get the data and say create table. Our table name could be warehouse. Okay, I can't write it. Warehouse reports, maybe, as the query again. Okay, this is our query, this is our table. If I just create this table, the default offset will be start from the latest, so it won't get the old data, that the 3 orders. If we want to get that old data as well, we need to set our auto offset reset to earliest. So how we can get that? I will just delete this first, and I will just say set auto offset reset to earliest. Yes, it is earliest. Yes, set offset earliest. Okay, now we can create our table, so we can calculate old data as well. Okay, so it's create table warehouse reports as blah blah blah. Okay, create our table. Okay, we have our table, right? So get data from our table, select everything from warehouse reports. Okay, this is warehouse reports. Yes, as you can see, we have our Gotham and Metropolis. We have 2 order count. If we wouldn't set our offset to earliest, we wouldn't have this data, and it will just start from nothing. It will just start to calculate the data from the new orders. ksqlDB have connectors, so we can get this table, a dashboard project, or for example Kibana, and get the latest and show the latest data for the customers or for ourselves. For example, in our DC world, we can, for example, get all warehouses and all the latest orders maybe within the last 24 hours and get the average product count for the warehouses. Or we can get this data from a REST API. So how we can get this data within a REST API? Let me show you an example. I will just clear it. So okay, I've cleared my terminal, and I will just create a new tab because we are inside of the KSQL, and get that data for the REST API within there. So in here we just get our data. We will just get our data with a curl. So this is our curl command, and in here, as you can see, getting our data from our ksqlDB query stream endpoint, and we just want to get the old data from our fulfillment order stream. As you can remember, this is our stream name and our table name was warehouse reports, and we want to get all the data, so we are setting our offset to earliest so we can get the old data as well, not just the latest. So run this data. As you can see, we have our all 3 orders, right? Order 1, 2 and 3. So let's get our table data as well, and that is, I've read that before, and this is our warehouse reports, just the difference is that, and run it, and as you can see we have our data. We just get our Gotham and Metropolis, our average product count and list city, and the total orders. And this is how different tables are from streams. But what would happen if the ksqlDB server crashed down, right? What will happen if we can't reach the ksqlDB of maybe the server is down or something happened by the network or physically to the service? We can't know. Would we lose our data? How we can trust ksqlDB? What is going on under the hood? ksqlDB actually holds this key value data with the RuxDB project. And what is that project? Let's see it together. Okay, this is RuxDB. Actually, ksqlDB table uses RuxDB under the hood, and RuxDB is a key value store, and it is an open source meta project. ksqlDB actually holds the data partition based on the disk with the RuxDB. When the ksqlDB crashes down and comes back online, actually get the whole old data from the changelogs topics. It's an internal topic, and everything that's written to the table actually goes to the changelog as well. Changelog topic as well, so the project can get the old data and continue to start where it was before. We can see that topic as well, as you can see in the AKHQ. Let me get to the topics. This is topics, and as you can see this says hide internal topics. I will just say show all topics so we can see the changelog topic, and that is in here. Yes, changelog topic for our warehouse reports table. And when I open it, as you can see we have messages for Gotham and Metropolis. So if something's happened to ksqlDB, it can recover actually with this topic. What do we have? We have warehouse, product count, and all the data the ksqlDB needs. And RuxDB is highly efficient for the bulk writes, so it can recover fast. I recommend to check their site. I'll share the link in the description. So this is in a sense what ksqlDB is. If you have any feedback, please leave a comment down below. Thanks for watching. May the force be with you.